So here we are, example 2, section 3.3, looking at cosine law. The diagram below shows the plan for a roof with support beam DE parallel to AB. The local building code requires that the angle formed at the peak of a roof to fall within a range of 70 to 80 degrees so that snow and ice will not build up. Will this plan pass local building code? Which means, is this angle here between 70 or 80 degrees? Which means I've got to do some calculations. Here, I know none of the angles, none of the angle measurements. None of them are right angle triangle. It's not right angles. It's not telling us that. I can't use SOHCAHTOA. I can't use sine law because I know I don't have any angles and I know I would need at least one. So that leaves me with cosine law. And remember what I said earlier, cosine law is going to be used in two instances, one where you have all three sides and one where you have two sides and the angle between. Here we have all three side measurements. We know that this is 10 feet, we know this is 20 feet, and we know this is 19 feet 6 inches, or really 19.5 feet. So we have our triangle with all three sides. If this is the angle we're trying to talk about, then this is the side that we need to start with. So I'm going to relabel my triangle on my new drawing as this being A, and I'll tell you why when I relabel and redraw my triangle. So here's my triangle. I know that this side is there, this one's there, kind of like this. This is 19.5. What was this? 10, and this was 20. And we said we're looking for this angle. Now, because of the format of the formula, if I know this formula, cosine A is equal to a squared minus b squared minus c squared divided by minus 2 or negative 2 times b times c, that means the angle that I'm looking for has to be angle A. So I relabel my triangle so that angle A is in the right place. So I'm going to call this A, although in our drawing it was B. This would be side A. B and C don't matter where they go. B and C. And I substitute into my formula. Knowing that I need an angle, I know that my formula is cosine A is equal to a squared minus b squared minus c squared, all divided by minus 2 times b times c, which is going to be equal to 20 squared minus 19.5 squared minus 10 squared, all divided by minus 2 times 19.5 times 10. Start to calculate. 400 minus, it's 19.5 squared. I think I have that written down somewhere. 19.5 squared is 380.25 minus 100 divided by negative 390. Negative 390. So now I calculate the top. 400 minus 380 minus 100 is going to work out to negative 80.25 divided by negative 390. Find yourself that decimal number. Cosine A is equal to 0.205769238. Remember, you know you're calculating for an angle. My last step has to be that inverse function of cosine, so angle A is equal cosine minus 1 of 0.257692308, which is equal to 78.125 5467, or 78 degrees. And then, of course, to answer the question, well, does this fall within 70 or 80 degrees? Yes, it absolutely does. Yes, it will pass building code.